Hey, everybody, I'd like to welcome you back to the Audio Programmer Podcast. And it's been a little while, and we thought that we would spin this back up again and hope to get some great guests in here just so we can talk about all the things that we love talking about, like DSP, audio programming, and so on. And this week, we have a very special guest with us, Ivan Cohen from France. How's it going,
Hello.
Ivan? So Ivan is joining us, and he's a very experienced DSP engineer who has released and done work with a number of different companies, and he's also contributed to the JUCE DSP module as well. And so we're going to be talking a little bit about that. So before we get started, if you'd like to hear more stuff like this, be sure to join us on Patreon at patreon.com/the audio programmer. And also join our Discord community on theaudioprogrammer.com/community. So Ivan, yeah, it's great to have you here. And I think one place that we could start is maybe just talking a little bit about your development journey. Can you just tell us a little bit about how you got started, what interested you in development, and what led you to get on the path that you're on now?
Yeah, sure. Wow, it's a big question, isn't it? I think I started doing DSP in 2006. I was doing a training course in a company which is called Two Notes, which wasn't exactly existing at that moment. But Guillaume Pil was starting his company in this very specific moment, and I was doing digital signal processing engineer school. It was my last year, and I was desesperating trying to find a company to work with for the last part of my school.
And what school was this?
So it's a school which is called Polytech Marseille.
Okay.
Marseille, like the city I'm from, which is in the very south of the France. And we did, Guillaume and I, together at this moment, the very beginning of all the Torpedo product line, which is a guitar amp cabinet simulator, which existed first as a hardware unit and then was developed as software plugins too. And so that was the very, very, very beginning of my DSP engineering journey. And then after that, I did also my PhD thesis with the IRCAM, which was about guitar amplifier simulation. I did also some additional studies just before that at IRCAM, which were really, really oriented to all the stuff that audio DSP engineers care about. I was only doing a school with a general DSP before, and at this point I was doing something really, really about audio. And then I think I have been working with Two Notes for like 6 or 7 years, from 2006 to 2013, I think. And then I started my career as a freelance developer. I start doing this by working with Sonic Academy. I did a lot of work related to their synthesizers, ANA 2, ANA 1, ANA 2, Kick, and a few other things that they were working on at the moment.
Yeah, and Kick was really huge as well, wasn't it? Well, all three of those products were really big at the time, weren't they?
I wasn't really paying attention to all the companies doing synthesizer at that time. It changed a lot after that to me.
Yeah.
But I heard, that Kick was something huge at that moment. They had also a collaboration with Nick Romero, I think, at some point.
Yeah, Nicky Romero. Yeah, yeah.
And the funny thing also with this company is that their main job was producing some tutorial videos about producing, about mixing, about using synthesizers.
Yeah.
And the plugins was kind of a side job. And then they were doing more and more plugins, and I don't know how they are about that at this point now, but I think they are doing both with the same amount of resources now.
Yeah, yeah.
A lot of people love their synthesizer Ana 2 at the moment, and I have been very proud to work on it and contribute to the filter side.
Yeah,
because most of the work on Ana has been done by other people than me.
And that was quite a big project. I think that
it's something huge.
Yeah, I think
is something very big.
Yeah, I think people, a lot of people don't really know how big a synthesizer project is, especially something of that level of complexity, or something like Serum. You know how complex it actually is. That's a very, very big project.
Yeah,
yeah. How long did that take? The whole project.
I think I have been working with Sonic Academy for like 2 or 3 years.
Yeah.
And I never really worked on a project from the start to the end. I started to work on Ana at the end of the version 1 and at the beginning of the version 2. I did something similar with Kick and some of the other projects.
Yeah.
But they had at that moment a lot of things they were working on, and enough work for thousands of freelance developers, I think.
Yeah. Yeah, I've done a little bit of work with Sonic Academy myself. So big shout out to Phil Johnston if he's listening in. So Phil's great. Phil's really a great guy. But yeah, they've done really well. And Kick, I believe Kick was, because I was producing music at the time, and Kick was one of the first plugins of its kind. The first one where you could actually synthesize a kick, and that must have been quite a difficult project to do. I can imagine, just the process of making, and there are so many different types of kicks as well, isn't there?
And and for each kind of electronic music, you have different kick that you can use, either synthesized or using samples.
And
it's amazing the number of samples libraries that you can find on the internet related to drums samples. For electronic music, you have like thousands of samples available just to emulate 808 drum kits.
Yeah. Wow, that's really interesting. And what was your work specifically for with Ana 2? You did the filters, right?
For Ana I did the filters code, and for the project I have been working on, I was doing a lot more stuff. I think I did some code porting from a framework that I didn't know to JUCE, JUCE SDK.
Yeah.
Because they were working with other freelance developers who had their own frameworks.
Oh man.
Yeah. Feel the pain. And I did some DSP related stuff as well in this project.
Yeah.
I worked also on some audio effects that unfortunately have not been released yet for a lot of reasons. But I did a lot of stuff for them.
Yeah.
And honestly, I felt really, really grateful to them, because that was my first job as a freelance developer.
Wow.
Of course, I had already some experience in DSP and JUCE coding before, but I had the feeling that the first month I did that as a freelance developer and not as someone hired fully by a company, were very helpful to me because even if I did know already DSP at that time, I wasn't that good at JUCE coding at that point because coding some JUCE plugins wasn't my job. In two notes, what I did was mostly DSP and research related things. So I think I really, really did learn how to code properly a JUCE plugin when I was working with Sonic Academy.
Yeah. One thing that I've always been curious about is just in terms of custom filter design and just really thinking about, okay, when you have a company that is looking to design a filter for a synthesizer, why? One of the questions that comes to mind is, okay, why are we going with a custom filter design here rather than just say grabbing some sort of Moog, the coefficients that you would need for like a Moog emulation filter? Why? What's the benefit of doing like a custom filter design, and also what do you have to do? Like what sort of work is involved there in terms of filtering, in terms of figuring out the right sound for you?
Big question again.
Yeah.
Well, that's funny because I don't think I'm that knowledgeable about the synthesizer filters, in fact. And that's funny because I have been playing with the plugin called The Drop from Cytomic, Andrew Sipper, recently. And he was asking me what I thought about it. And
for people that don't know, Andy Simper is probably one of the leading DSP developers in the industry.
Oh yeah, and the work he did on his plugins is really amazing. I think the filters model in the drop, and for example, the work he did in the Tube Screamer modeling plugin are probably the most complex and complete models you could find for this stuff as audio plugins. And I told him that sometimes when I was using the drop for demoing it, I wasn't able to find out which filter would be the most beneficial to me for a given use, because you can choose a lot of filters there the same way that what is Anna actually, because Anna has a lot of different filters. I think you really do have to be totally into analog synthesizers to really know properly this stuff. Like, okay, if you take the Moog filter, you will be able to get that sound for that specific use. For example, that filter is good for bass sounds or for this kind of leads. But if you want a lead which sounds like this record on this album, you need that synthesizer, and the sound of this synthesizer is all about the amplitude envelope and the filter. So you need this filter to do that thing, etc., etc. I think when you have to choose one filter instead of another, you need to know a little bit all this stuff before just using the plugin or the synthesizer. And I'm not enough into synthesizers and electronic music to have this knowledge. I could do something similar to that related to guitar amplifiers, for example. I know that this high gain guitar amplifier is good for this kind of heavy death metal sound. That's my music, the thing I hear, the thing I listen, the things I know. But for filters, I don't have this knowledge. But even if I don't have this knowledge, if I see the analog circuit schematic, I know how to properly model a simplified version of that. And even for analog modeling stuff, I think I'm not as good as people like Andrew Simper or the people that are actually running the company Neural DSP.
Yeah.
Which is a company which has released a lot of guitar amp sims.
Mm-hmm.
And they are working at the moment on their first hardware product.
Yeah.
Which seems to be very good.
Mm-hmm.
The only thing I know related to virtual analog modeling is how to simulate in a simple way those analog circuits in a way that is relevant, so you can recognize the sound, but it's not something that is going to be 100% realistic, because often I don't know exactly how they have to sound, because I don't always have the original circuit in its real form just in front of me, so I can only model the thing that I see in the electronic circuit.
Yeah.
And I have some knowledge related to this, but I won't say either that I'm a noob related to virtual modeling, but I have still tons of things to learn, to understand before being able to do something like the guys that I have created just before.
Yeah.
But it's enough to do something that is useful for musicians.
That's right.
And when I was working with Sonic Academy, they weren't asking for things that are 100% realistic. They wanted to have a big framework of different filters with different properties. So I coded a lot of them, and they grabbed the one that they liked the most.
Yeah.
They put them in their synthesizers.
Interesting. And when another,
I think I have answered to half of your question, but
and another question. So a lot of people bring up, of course, when you're doing any sort of analog emulation, people talk about the non-linearities that happen when you're turning the filter and you have a certain character that you have in old gear because they're actual analog circuits that are actually happening. And do you work to recreate that when you're doing even a rough model of analog gear? Are you looking to recreate that invariance, or do you pretty much accept that, okay, these are going to be, it's not going to have quite the character? How do you handle that?
Generally, when I start working on a specific electronic circuit, I'm using an application which is called LT-Spice. LT-Spice is an app which simulates offline all the electronic circuit you want. You just have to write the content of the electronic circuit. It uses some internal models for each analog component, and then you push the button run simulate. You wait for thousands of seconds, depending on the complexity of the electronic circuit, and you get something that could be your reference to what you actually want to get from a simulation in a plugin, because it uses methods that are not simplifying anything in terms of model complexity, in terms of coupling between the electronic components. So the result you get is the one you would get with the best simulation ever that you could use in a plugin.
Yeah.
So I use that as a reference. You can send tons of different signals inside the electronic circuit in the simulator. For example, sines, triangles, but also wave audio files. If you want, you can record the outputs of a distortion pedal using a dry guitar sound as an input.
Yeah.
You can export the result as a WAV file, put that in your Reaper or Ableton Live project, and get a hit at radio thanks to the LT-Spice modelization.
Wow.
That's something that is very, very interesting.
Yeah.
And once I do that, I know more or less what are the most significant phenomena that happen in the electronic circuit.
Mm-hmm.
Because I can also see the wave shape of the signals going into the circuit at different nodes. At every single node in the circuit, I can just click somewhere and see, okay, here we have the distortion that is going on. Here I can see that there is some filtering things.
Mm-hmm.
And I use that as a reference to the work I do after.
Yeah.
And then one of the methods I use to do analog modeling is called decay methods.
Okay.
It's something that has been developed by David Tillet,
Okay.
someone who did a PhD thesis about guitar amplifiers too. And his work was inspired from other work from other people, like, for example, Federico Fontana.
Mm-hmm.
And after his thesis, a lot of people have improved this method to make it more optimized, to make it work for various kinds of circuits.
Mm-hmm.
And that method is basically a way to take a netlist, so a text file
Mm-hmm.
where you have the description of your electronic circuit, and transform that into matrices with
Mm-hmm.
numbers inside that you can directly use in your C++ code to do the simulation of the circuit.
Wow.
And so you can, for example, write manually the netlist of a circuit in a JUCE app,
Mm-hmm.
and then simulate that, and then you can get in real time or offline the simulation of the circuit, which calculates the relationship between all the electronic components in the electronic circuit, the fact that they are connected in certain ways and not other ways.
Wow.
So that's the first most important thing here. And the second is then which electronic component model you have to use.
Mm-hmm.
For each electronic component in the world that you're going to simulate in your processing, you need to have a proper mathematical model.
Mm-hmm.
For stuff like resistances, capacitances, inductances.
Mm-hmm.
In general, people use linear, very simplified models.
Yeah.
Which are just things that you can write with, say, one equation.
Mm-hmm.
And then for other electronic components like tubes, transistors, diodes, transformers, and stuff like that, you need to use a lot more complex models.
Mm-hmm. Mm-hmm.
And then you put these two elements together, and you get a list of equations that you have to solve in real time in your simulation code. And to do the simulation and to get the results using your audio signal as an input,
Yeah.
you need to do a lot of stuff like solving nonlinear implicit equations, choose ways to simulate the dynamic stuff like what happens in capacitances, which have filtering behavior on the audio signal.
Yeah.
But basically, you have your matrices, which relates to the organization of components in the electronic circuit. You have your mathematical models. You have methods to solve the equation you get from that.
Mm-hmm.
And all this stuff together gives you a real-time code that can be used on any audio signal to do the whole simulation. That's more or less what we do. Sometimes when we try to simulate very, very complex circuits, you can just grab the matrices that you get from the wall circuit as a wall. You would get a very, very big matrix,
Yeah.
which is impossible to process in real time because of the number of columns and rows.
Yeah.
So something that people working on guitar amps do a lot is cutting in several parts the electronic circuits, parts that we call often elementary stages.
Mm-hmm.
So we can simulate each elementary stage on its own, and then we find a way to simulate the coupling between those elementary stages, so we can get what happens when they are connected with signal voltages, currents going in one direction or in the other direction at the same time, because you can't just simulate them separately and take the output from them and connect it to the input of the next one. It doesn't work. You have to consider the fact that everything that happens in one elementary stage has an influence in what happens in the next, but also in the previous ones.
Yeah.
So you need to find a way to get the benefits of using elementary stages approaches, but at the same time simulate the coupling between them. And every single time you have a complex circuit to simulate, either a guitar amplifier or something with less components like a filter synthesizer, a synthesizer filter, you always need to figure out where you can do some simplifications. Because you can just do the simulation in a brute force manner without sacrificing the real-time constraint.
Yeah.
You have to say, okay, that part is something that has not a lot of influence into the signal, into the result. So I can just remove it or use a very simplified model for it. And sometimes the issue is that you don't have the complex models for a given component or a given thing, whatever it can be. And you need to figure out how to add more complexity in what you're doing. So sometimes you have to do some stuff to add some complexities.
Yeah.
For example, during my PhD thesis, my team and we designed a device to measure what is going on in vacuum tubes, and specifically in triodes. And so I had to spend a lot of time sending signals through single triodes to generate mathematical models that could be used in AntiSpice first, and then in audio plugins.
Wow.
And sometimes it was a little painful experience because I took a lot of electric shock by connecting the triode to the measurement device, and the measurement strategies needed a lot of time to get all the points we need. But I think that's one of the contribution I did to this area. Finding ways to measure these tubes and giving some models that can be used in AntiSpice. And I know a lot of people working on synthesizer stuff do the same for transistors, for diodes. And for example, it's very complicated to get all the parasitic capacitances behavior that we have in triodes or in diodes or in transistors. So at some point, when you want to do something realistic, you need to get the real circuits, not only to see if what you're doing is right in comparison to the real thing, but also because you need at some point to take the little components and do some test measurement on them to be able to create great mathematical models for them.
Amazing. And so everything, correct me if I'm wrong, but everything that you've described up to this point has been what they call white box testing, correct? Where you're actually modeling the individual components. So for people that may be unaware, there are these terms that are kind of tossed around called white box testing, which is what Ivan is describing as actually modeling each individual component of what is happening in the analog world and trying to mimic it in the physical in the digital world. And then you have what's called black box testing, which is you would know better than me. But can you tell people about the difference between white box and black box testing?
Yeah. And actually, I was doing also some black box approaches modeling with 2 notes, because all the guitar amp cabinet simulations that have been done by them are based on, but not only based on, convolution processing. So I spend a lot of time too sending sine sweeps of like 30 seconds to cabinets with a lot of power to send the signal from them. So my ears were literally crying for hours. And when it was done, you had to move a little bit the microphone in front of the speaker and do it again, and then move again the microphone and do the sine sweeps and again, and then you could change the speakers, you could change the microphone, and a lot of stuff like this.
Yeah.
And at the end, you could get some recordings that can be processed with things like Voxengo deconvolver application. We had our own to do that stuff, but that's something people can do. You can simulate using the convolution black box approach anything using the application called Voxengo deconvolver. It gives you the sine sweeps that you have to send to the system you want to model. You send the sine sweep to it, you record the output, you put the output in Voxengo deconvolver, and you will get an impulse response that you can load in your preferred convolution plugin that you use all the time.
Yeah.
And you'll get a perfect simulation of the linear side of things for the system where you put the sine sweeps. So that's something I did for two notes, and they use other methods to model the non-linearities, but it's the black box approach. Basically, the difference between white box and black box approach is that with white box, you model everything that is happening inside the system, and you need some knowledge of what is happening inside. You need to use a physical modeling, put integrations, all the stuff that is happening inside. And sometimes it's not practicable to do that. And you want to use the black box approach instead, where you don't need any knowledge of what the system does. You just need to send signals through it, record those signals, and using the results, you can get an impulse response or anything that could be used to simulate the system. And convolution is a mathematical operation, which is very useful for doing that. But it's useful only when you want to simulate something which is absolutely linear. Time invariant linear, more specifically, which means that the behavior of the system is not moving with time. So you can simulate a chorus, for example, using that. And it's perfectly linear, which means that it doesn't generate any harmonic. It's one of the definitions of something which is linear.
Yeah.
So for reverberation, it's perfect. For cabinet simulation, it's not exactly perfect, but it works somehow because they are weakly nonlinear. But if you want to model the nonlinearities of speakers, you need to do something else, either on top of the convolution approach or totally different from the start. So there are the differences. And today we have a lot of stuff happening for audio developers and musicians in an area which is called machine learning. And basically, machine learning is a way, among other things, which could be used to model nonlinear and time variant systems using a black box approach. I know that, for example, some people have written articles recently about the modeling of distortion pedals using machine learning, using a specific approach of deep learning that I don't remember because I don't know very much this area myself. But the amazing thing is that they had to train their neural networks using recordings made on the original pedals. And once the network is trained, you can use it in a JUCE plugin like this. And it will simulate perfectly the snapshot of the pedal that you've taken using the training and the machine learning approach.
Yeah. The disadvantage is that normally it takes a ridiculous amount of computer power, though, doesn't it, to do this? Yeah, well, that's what I've heard anyway.
And sometimes you have people which does white box and black box approaches at the same time. For example, I think, but I'm not sure 100%, that the Kemper profiling amp, which is a hardware product which uses a black box approach to simulate any audio amplifier, is using a white box kind of model of a guitar amplifier internally with tons of customizable parameters. And then these parameters can be estimated for a given amplifier using signals that you would send to the real amplifier in the real world.
Yeah.
And the result you get from these recordings are used to get the best fit for those parameters to make the model and the original look like as much as possible.
Yeah.
And it's true also for pure white box approaches. When you have something that is more or less properly working, and then you take the real synthesizer filter, the real pedal, and you try to make your model and the real thing sound more or less the same.
Yeah.
So you will change some parameters of your model to make I don't know, the frequency responses of both be a match as much as possible.
Yeah.
So in general, it's very rare that people use only one kind of approach and the other and the other side. Maybe for all the stuff related to convolution processing, for example, for reverberation and simulation, you wouldn't need to model the acoustic room behavior to make your impulse response or your process sound the same as much as possible.
Yeah.
But even there, sometimes you have some post-processing on the impulse responses to make them sound a given way or another. So it's just toolboxes that you have, and you use all the tools you need for a given task.
So there are so many questions that I have. I guess another one of a question that I think a lot of people might be wondering is, I mean, this sounds like such a specialty in itself, doesn't it? Just this on its own, before you actually even introduce the coding and that part and the multi-threading and all of this other stuff into it. So my understanding and my experience seeing a couple of these companies from the inside is that a lot of companies really only have maybe one or maybe even just a few people that actually specialize in the DSP part of that. I mean, has that been your experience as well?
Yeah, sure. Actually, a lot of the people that have contacted me for freelance work are either interested in someone who just do some JUCE coding and nothing else, and some other want some very, very specific DSP knowledge and have already some people doing the plugin coding itself.
Yeah.
And I think that all the freelance developers like me who have those two skills at the same time are very rare, in fact.
Yeah.
It's just coding a JUCE plugin is something very specialized by itself. I mean, I don't think the JUCE team has thousands and thousands of clients buying their license, but having someone which is both more or less good at DSP and at coding and say at I don't know, designing graphic user interface, all these things together. The more you accumulate these skills, the most you are alone doing this, in fact. And it's just insane if you think about it a little, how many skills you actually need to be able to code and to release a commercial plugin.
Yep.
If you look at all the skills that you need from the start to the end of the job, and I'm not only talking about the very, very necessary skills, but also the optional ones, but which could make a difference in income, for example, for the guy doing this.
Yeah.
I know it's very difficult for one company guy to be able to handle the coding, the design, the project creation, the DSP part, the anti-piracy part, the marketing part, the business part, all these things together, the support, with all those people asking you to add more features in the things you have just released.
Yeah.
It's an insane job.
Yeah.
I mean, you can find anywhere in the professional industry, whatever the area, as many skills needed for doing one job properly.
Yeah.
That's the reason why the companies that have a lot of employees working on audio plugins have actually people doing only one or two things at maximum.
Yeah.
That's the reason why they hire many people. But when you're all alone for doing all this stuff, it's insane the amount of things you have to learn to be able to release something.
Yeah.
And so if we just focus on the coding and DSP part of things, even just for that, I have the feeling that we are not a lot in the world having those skills, not because we are the smartest guys in the world, but because at some point you need to ask yourself, what skill do you want to develop? What do you want to learn? And we are not a lot having actually think about, yes, I want to learn that, and then I'm able to do that specific job in a very niche market for a very small potential clients.
Yeah, that's it. Just even when you just think about the fact of creating a plugin, let's say you design it and you've done all the DSP, you've done all of the UI, you've designed it, then you put it out. It's impossible to test your plugin or your audio app for all scenarios, all different operating systems, all different.
Some companies have people doing plugin testing all day and only that.
Yeah. So you have multiple operating systems. You have multiple DAWs that have their own little quirks. And if you're an indie developer looking to release a product, you have all of these systems that you definitely have not tested your plugin on, and you're going to get crash reports, and you're going to get these things back, and you're going to get probably an avalanche of.
And when you release a product, the last thing you want to do is spend thousands of days on it just to solve bugs. Of course, you can if there are serious bugs, you have to solve them. I mean, it's stupid to sell something which is full of bugs, but sometimes you don't want to have to support a product you have released, I don't know, 10 years ago forever.
Yeah.
That's the reason some companies at some point just stop supporting some of their previous plugins and just remove them from their catalog. But the journey of a freelance developer like me or someone which is only doing commercial plugins can be very complicated. You need to spend to find a way to sort out what you want to do in the job. Do you want to learn new skills?
Yeah.
Do you want to work on new products? Do you want to do some music also? That's a plague we all have. At some point when you start doing audio development, you do that job because you love music and because you're more or less an intermediate or a beginner musician, and you start that thinking, if I work on the coding stuff, at some point I will be able to do more music during my work job, my work hours. And when you're experiencing enough, you forget about this idea. It becomes just impossible to do music and all the stuff related to handling your own company.
Yeah.
But at some point, you need to think about what are the skills you want to acquire, what are the projects you want to work on, and you have to make tough choices. And you have to say, okay, this part is very interesting to me, but I know I will never have the time, any time to invest on it. So I will forget about that part of things forever, so I can focus on the other things that are more important to me at the moment. And we will see maybe in 10 years if I invest some time doing so. And so I know a few developers, and I know that among the ones that are successful commercially, their knowledge in coding and in DSP in general can vary a lot. I mean, I know that some people are interested in virtual modeling, but they see that it would be too much time for them if they had to invest time to learn things properly. So they don't want to do that at all. They just focus on the skills they already have to develop the ideas they have. And you have some people that are very, very good at something and will release one plugin every 4 years. I don't know, even if they could do more, but they don't want to because maybe the products are already successful enough.
Yeah.
Or often it's because what they like the most is the research part of things, learning new stuff and improving the stuff they are already developed up to a given point. And when you have some very niche product made by one guy or two guys, often they have this profile. They've been investing a lot of time in. I will give you some very random examples. But for example, there is this guy who has done reverberation algorithms for 20 years.
Yeah.
And he has done a lot of reverberation plugins, and they are the best in the world, in my opinion, because he is the guy who is the most specialized in this. And you have another guy which is very specialized in virtual modeling, which has released a lot of plugins related to that.
Yeah.
Maybe he doesn't know how to do other stuff, but he does that because that's the thing he is the best at. And then you have a very big project like a synthesizer with a ton of features. When you look at them, you think that all the DSP stuff that is inside must be insane. But sometimes it is not. It's just basic DSP blocks assembled all together, which do this. But it's enough to make a good product and a successful product. So
yeah.
It's not about what is the best in the world should be in the best product. It's about the vision that all these audio developers have.
Yeah.
They have a given vision for a given product, which solves some issues for musicians. Maybe it's something that doesn't exist yet, or it doesn't exist with this particular set of features, with this specific workflow. And all those people are thinking about what would be best to put inside a plugin to have this vision fulfilled.
Yeah.
And sometimes you need a very basic DSP to do the whole product. Sometimes you need very complex, very advanced stuff. But all the approaches are good if the vision is fulfilled and if the product is good enough, I would say. So, I consider myself as, I would say, an intermediate level DSP engineer, but I know a lot of people who are a lot better than me in DSP related areas, in virtual analog modeling stuff. And it's often strange to me when people say about me, I'm a very experienced, a very good DSP engineer. I'm not. I spend a lot of time learning stuff that I like, that I needed. And I code plugins which uses this stuff all the time for me or for other people. But the thing that I do the most during my work hours and that I love the most in my job is actually learning new stuff and doing some research about things that I have not made good enough yet.
Yeah, and I think you bring up a great point, which is that there are so many people that when they get into this field, they really try to wrap their arms around everything, around DSP, around coding, around just all of it, and it's too much to wrap your arms around. There's too much out there, and as you said, I think one of the keys is really looking at what are you good at right now before you've even stepped into coding. You know, if it's music production, if you know a lot about guitars, if you happen to know a lot about reverberation, or you know, even if you happen to know just a lot about math and about linear algebra and about that side of things, you really have to pick and choose your battles. And then one of the biggest pieces of advice that I give to people that are just starting out is really take a good look at that and then try to build your coding skills and your knowledge base around those types of things. Because if you just try to tackle it all head on, it'll take you, you'll just never get anywhere really. Yeah. So it's very much about finding out and really taking a look at yourself and saying, what is it that makes me different, that makes me, you know, that gives me a little bit of edge of knowledge.
Yeah, that two sides of the thing, and what you just said is very interesting. You have the thing that you like. What would you like to do? Where would you want to invest some time to do something that would sound beneficial for you? Because just you would enjoy learning and coding stuff related to that. And what would make sense in the plugin market, and to say the things very earth on there. We are all working more or less on this audio industry with the very specific plugin market and all the stuff around related to other instruments, to the hardware side of things, etc. And all those markets are heavily saturated with things that are released almost every hour. Every hour you can find something new notified on KVR, on Gears, either a new guitar, a new electronic instrument, a new plugin. And you can just do something that exists already and say, okay, I'm going to sell 1,000 of them. So often you have to ask yourself, do you like working on this? And also, where could I make something relevant, knowing the actual market, and also, because that's also very important, even more than the plugin market and the business side of things. What are the things that doesn't exist yet that could be beneficial for our musicians? Where could I find something that a musician will instantaneously enjoy because he couldn't find something like this anywhere before? That's the kind of questions that I'm asking myself all the time when I think about new ideas for a product, or for algorithms, or for things that I would like to learn. And I think that's very important for all the people in this industry, either beginners or experienced. It's a question that they have to ask themselves all the time.
Yeah. And another thing when we talk about knowledge is the fact that we actually have a collaboration that's coming out soon, don't we? And yeah,
yeah, sure.
We should probably talk about that a little bit. Yeah. So as early as about this time last year, so maybe even about a year ago, Ivan and I had started talking and discussing because DSP is something that I've always been curious about, and of course there are people that know, of course, about the channel and about all of the tutorials that I have on the channel. And one of the biggest, I think, hurdles for any developer, including myself, is taking the step from making kind of a play project or a hack or a quick like hack a project together that works in a very basic way, and making the step and the transition into being a developer that understands how to sort of start optimizing and thinking about things from a higher level perspective, and really making the transition from a person that is just building a play project to somebody that's building a project that you can actually sell. So, Ivan, I guess I'll let you talk a little bit about our vision for this course that we've created together. Tell us, because you were actually the originator of I've actually kind of taken tutelage from you to help create the course, but tell us about your original vision for the course.
I think when we started talking about that, I was asking myself a lot of questions related to the ADC Audio Developer Conference talks I did in the past with the JUCE team. By the way, you can find a few videos with my great French English accents with me talking about stuff related to virtual and modeling processing. So I spent a lot of time preparing those talks, and the last time I was at ADC, not the last year, but the year before, I worked also on a DSP workshop. So when I created the content of this course, I asked myself a lot of times, what is the knowledge required to understand the things I'm working on. So the people who would attend to the course would be able to understand most everything. And what about the pace also of the course? Should I put tons of content so people could work on it in their home, or should I put less content so everything could be discussed during the workshop? I was asking myself all this question continuously during the design of the course. And then I did the course twice in a row during the DSP workshop day. And I was very, very upset at myself because I was overestimating a lot the knowledge of people attending there. I thought naively that we could do all together at least half of the content of the course during the workshop. And I was able only to do the very first part with the people there.
Yeah.
And I had to talk like in a talk and not like in a workshop. It could be with people talking, asking questions for all the other parts. So people were actually working during the workshop on the first part, and I would just talk myself for explaining everything in one row about the other parts. It wasn't at all what I wanted to do. And after this workshop, which was good actually, I think, because all the people had a lot of content to work on, and they asked me a lot of questions by email after the workshop. I was thinking, how what are the things that I would have done better there? How would I do something like that again after?
Yeah.
And I was thinking that finally DSP isn't something which is that much suited for the workshop format. Because this kind of workshop is good for stuff that you can acquire instantaneously, and you can just code things related to what the speaker is saying in real time. But for DSP, you need to have some basic knowledge related to a lot of specific areas, like mathematical stuff, specifically, and things more related to pure DSP in general. And then you have to play with the concepts a lot before being able to truly understand them. And when I was doing some lessons, because I do that a lot of time when I was doing some DSP lessons with people on Skype. In general, I was only able to cover a given topic, for example, I don't know, filters, FFT, things like that, in 2, 3, or 4 hours minimum.
Yeah.
So with all this stuff in my head, I was thinking that there is a need for something like DSP course with videos where people could acquire the basics first, at their own pace, and then they could be able to learn all the more complicated stuff once those basics are properly acquired with the requested proper amount of time.
Yeah.
And so that's around that time that we started discussing together what would be the best content for a DSP course.
Yeah.
And I remember at the first moment I was thinking about, okay, we should put some stuff related to filters, and then we should speak about the very basics of virtual node modeling, and then we should speak about FFT, then we should speak about this, and then we should speak about that. And then I remembered that one of the guys who was attending on one of my DSP workshops, so he actually paid for it, was asking me at the very, very beginning of the course, how should I install JUCE in Linux?
Yeah, yeah.
And then I was like, okay, I won't do the same mistake again. Let's do instead a proper DSP course covering only the very, very basics.
Yeah.
Which could be used as a reference for all the things upcoming after.
Yeah.
And then we started discussing about what would be this basics DSP course.
Yeah.
And then we thought about doing something which would be about making a basic plugin project using JUCE.
Yeah.
And it could be used as a basis for all the stuff that we could think about after.
Yeah.
I was even thinking about doing something about using the Soul language instead of JUCE.
Yeah.
We've been talking about this a lot together.
Yeah.
But since most of the people who could be interested in the course are interested in the plugin side of things most of the time.
Yeah.
We thought it could be better to really do something properly about the plugin side of things first. And then we could start using that to put more stuff on top.
Yeah. And what's really cool is that now Jules and Cesare, who are the creators of Soul, they've actually created functionality where you can actually take Soul code and you can actually convert it into JUCE code. So this could be something useful for the future, definitely. And yeah, exactly. So one of the most important things I think is that I think as a developer gains more and more experience, and I say this from my own perspective as well as a person that has only been doing it for a couple of years, but there are so many different angles that when you're actually creating something and you're thinking about things from so many different angles. And the thing is that once you've done that a couple times, it becomes a very natural thing to do. And so it can be very easy to assume or to gloss those things over for people that may just be starting out. Like now, for me now, the use of atomic variables, for instance, is something that I would just think about quite naturally. So atomic variables, for people that aren't aware, are when you have shared data that's being used by two threads at the same time, and one thread may be trying to access what that data is at one moment, but another thread may be trying to change the data at the same moment. And so an atomic is a way that it actually protects those two threads from from actually accessing the data at the same time so that you don't get into a race condition. But now I'm starting to get into a good habit of being able to use atomics, and I don't even really think about it anymore. But for somebody that's just starting out, it could be easy. I might just really just talk about it very quickly without even explaining what it is, and that it can be easy for a person that's just starting out to get lost. And so what we're trying to do is this first course is very much a foundational course just to explain those things, those very basic concepts, and also the things that before you even start getting into the math of DSP, there are all of these kind of little kind of bits and pieces of knowledge that you have to be aware of before you've even gotten into the math of actually doing DSP. And some of the stuff like accessing data from different threads is one of them. Another one is when you're trying to take a DSP process and you're trying to apply it to more than one signal. So if you have like a stereo signal, you have to do different DSP. You have to have two copies of the DSP process and have one process for each speaker or each signal that you're applying it to. So there are all these little bits that we thought about. And so this first course is very much a foundational course. And what you'll find is that the plugin that you actually end up at the end with isn't really what I would describe as like, you're going to have your own commercial product that is going to be like ready to release and you can just throw it on Plugin Boutique and it's going to be ready to go. But you will have the knowledge of, okay, this is the extra step that I need to be able to take in order to take what I've been making and actually start making this into a real product that I could actually sell. So I think that's the main difference there.
Yeah, and I think also that one of the reasons we have decided to do that course is because we both really love JUCE, right?
Yeah.
I mean, when I started doing plugin development, JUCE wasn't able at the moment to compile VST plugins. It was just something that you would use to do audio applications.
Oh, wow.
Like Traction, which is the digital workstation, which was needing something like JUCE, and that's the reason why Julian Storer designed JUCE in the first place.
Yeah.
Was to create Traction. At that time, you couldn't do plugins with it, so my very first VST plugin used only the VST SDK and the very first version of the user interface thing that you can use now with the VST SDK. And it was really painful to use.
Yeah.
And you didn't have the multi-platform stuff, etc. So the JUCE for me is something very important. In my work days, I use JUCE all the time.
Yeah, yeah.
But JUCE also is its issues, and one of them is the documentation for beginners. And since the framework itself has changed a lot over the last years, even if they do tutorials every single year, the tutorial would be deprecated very quickly. So I think today, when you are a beginner and you want to go from I know C++ to I know JUCE enough to be able to release a commercial plugin, some steps to get there are obvious. Some of them are less obvious, but you could get some information quickly by asking questions on the JUCE forum, or just by looking at all the information that you can have on the internet related to that. And some of them are almost hidden.
Yeah.
It's stuff that audio developers might know and keep for themselves without really doing it on purpose.
Yeah.
And some of the steps are stuff they are been working on for a long time with a lot work being done on specific ways and specific parts, etc. Mm-hmm. And they truly want to keep that work for themselves because they have invest a lot of time on it. Mm. And when you're a beginner, you don't have an access to this code, this knowledge, and even to the fact that you don't have all the pieces you need in JUCE to do something. Like, to me, the best example of that is preset managers. Mm-hmm. You don't have embedded preset managers in JUCE. And every single audio company has coded its own preset manager in a way or another using some pieces that are already available in JUCE or not. Sometimes I know that some people have asked other audio developers who are using JUCE to give them their code for preset managers so they could use that as a basis to build their own version of the thing.
Yeah.
And that's insane because some things in JUCE are so much over engineered that you would never ever just think about the idea of trying to find something which does the same thing in the outside. I mean, you have all the things you would ever dream available to you in a specific class.
Yeah.
And then on other parts of the stuff you need to make plugins, the SDK is lacking a lot of things. Mm-hmm. And the documentation doesn't give you all the information you need, for example, to handle plugin parameters the best way. Mm-hmm. So I think the amount of work needed for beginners to be able to release commercial plugins using JUCE is insane.
Yeah.
And improving the documentation of JUCE is something I know the JUCE guys are going to do in the future. Mm-hmm. But in our side, we thought that it would be a great thing to put some intel related to these steps that the beginners need to overcome.
So one thing that I've thought about when coming into this industry and still being very new to this industry is about how much similarity it has to kind of sound engineering and music producing back in the 70s and 80s, and how back in the day, producers and sound engineers didn't really have access unless you went to a studio. You didn't have access to the knowledge, and there was nowhere where you could just read about how to master or how to properly produce a track. And it was almost like just knowledge that people would share maybe by the campfire, with each other, and it would be passed from generation to generation. That's what I see with plugin and audio app producing as well, in that you have a lot of knowledge that gets talked about and shared, and it's stuff that is not obvious. It's not stuff that you would just know or be able to really figure out kind of inherently without spending a lot of time and a lot of experience doing these things.
And it's the same thing, for example, with guitar playing.
Mm-hmm.
And even more with this specific instrument, because that's not something which you can really learn in standard audio schools, depending on the kind of music you do. For piano, I would say that if you learn how to read sheet music, if you learn the theory, at least you could start doing whatever you want.
Yeah.
But for specifically for electric guitar playing, most of the important stuff that you can hear in rock or heavy metal records, are things that you couldn't learn in the 80s by attending to a music school.
Yeah.
So when someone was able to do a specific trick using his guitar, you had to go ask to him directly how he would do something like that.
Yeah.
And at the end of the 90s, you could see a lot of great guitar players releasing video workshops, teaching how they organize their work, the hours in a day, and it was very, very successful. For example, I don't know any very good, fast guitar player who has never heard about a video from John Petrucci, the guitar player of Dream Theater, which is called Rock Discipline.
Wow.
It's probably the most successful one.
Yeah.
And it shows that some of this knowledge wasn't available at that time.
Yeah.
In music schools. Now things are different. Some music schools have started investing some time into jazz. You know, the thing that no music school could ever want to hear about in the 80s. And then some of them can make you learn things related to rock, to metal, etc. But before the era of internet and YouTube videos everywhere, some knowledge was really, really hidden to most of people.
Yeah, absolutely. And so this course is really designed to start sharing some of those things that aren't so obvious for people that are just starting out, and really giving you, more than anything, a foundation for Ivan and I to come back in the future, in the very near future, to start building on that and actually start going a little bit more into the DSP and a little bit more into the actual making of audio algorithms. So that's going to be available very soon. You can actually sign up using the link below. I'll put a link below for you to sign up, and there will be an announcement date as well for that. So yeah, I hope you enjoy it. And there's an ebook as well. So we have a 40 or 45 page ebook that you'll be able to read through if you like reading rather than watching the videos. We have over 3 hours of videos, and we have the GitHub repository where you can actually pull the code from GitHub and you can follow along, or you can read along, however you prefer to do it. And we're going to have a private room in the Audio Programmer Discord as well, where you'll be able to ask us questions and actually get help in real time if there are parts that are unclear to you or you need help getting to the next step. So there you go.
So I think the next step are going to be related to all the DSP stuff that I thought to put initially in the DSP course.
Yeah, I think that's a great one. So as I mentioned earlier, Ivan has worked on the DSP module that's already in JUCE, but of course JUCE 6, if it's not out by the time this video is out, is coming out very soon. And you've done a lot of work on the new DSP module as well. Can you tell us a little bit about what's going to be coming up in JUCE 6?
So the things I've been working on for JUCE 6 are all in the DSP module. The first thing I did was adding some basic audio effects that some beginners would have loved to have in JUCE before, like a basic compressor, basic limiter, a phaser, a chorus, things like that. So there is a new folder now in the DSP module, which is called Widgets, I think, which is basically a library of audio effects like that. And I think a lot of people will really, really enjoy to have those classes directly inside JUCE, so they could make music with it, because JUCE is not just something that you use to make commercial plugins, but some people use them also to create songs. I mean, they create an audio effect very personal to them, and they do stuff with that.
Great.
So we thought it would be a great thing to have some basic audio effects in JUCE, because some people are using JUCE to create some personal audio effect they could use to make music.
Yeah.
Or to make a basic audio effect they could love to use in their digital audio workstation.
Yeah.
And it's a great thing to have a basic compressor, basic phaser in a framework like that, since I know a lot of other audio frameworks like Maximilian or STK have basic audio effects and things that you can use to make music as well.
Yeah.
So it was something that was, I think, requested a lot to the JUCE team, and it was logical to do that at some point.
Yeah, absolutely.
In JUCE 6, I'm going to open the JUCE 6 folder, so I will remember things I have been doing on it.
Yeah. And and while Ivan's doing that, one thing that's really cool about JUCE is that you can actually see all of the code as well. So there are no black boxes, nothing, no sort of libraries that you can't open up and see the code. So you'll actually be able to see the actual math. And I think one thing that's awesome about that, I say this not having taken a look at it myself, but that of course that the JUCE team are some of the best framework developers in the world, and that even Ivan has been really thoroughly impressed by the work that they've done to optimize these DSP algorithms, and they're really superstars. So big shout out to Ruben, Tom, and Ed, and for the hard work that they're doing. And so you'll be able to see as well best practices in terms of the way that they've optimized it.
Exactly.
So,
and I think that's one of the only framework that I have ever used that allow you to create a project and make it compile on the first time when you do the build thing on Xcode or Visual Studio. I think it just doesn't happen with all the other frameworks in the world. There is always something that you forgot, or I don't know.
Yeah.
For that, JUCE is really, really, truly amazing for that and for a lot of other things.
Yeah.
So in JUCE 6, was very important addition too is the class delay line. That's something that has been requested a lot. And having this in JUCE 6 was also very helpful to me because it allowed me to add a lot of very cool things. And for example, I have been able to optimize, to improve, I would say, the oversampling class by adding a delay line somewhere in the signal path to compensate for some issues we could have with the additional latency that is sometimes not fractional. And using the delay line to do that allow us to use oversampling in a better ways for a lot of reasons. I would talk about the JUCE forum at some point.
Yeah.
But I'm using this class all the time now. It has been used also in the new widgets, like for the Chorus class. Then I start working on some improvements of the new of the DSP convolution class that was a feature in the last iteration of the DSP model.
Yeah.
And it has been improved a lot by the JUCE team to remove some thread issues that were in my original implementation. And I'm still working at the moment at some additional improvements to make it as efficient as possible. But basically, the two main features of the new class is that it uses now not uniform convolution, not uniform partitioning convolution algorithm. So people will be able to use that class with very long impulse responses.
Yeah.
And the other feature is, of course, the fact that now it should be perfectly thread safe in all the possible contexts.
Yeah.
And one very important and extensive extension of the JUCE 6 DSP module is the addition of interpolators classes, and specifically one which is called window sync interpolator. Which is going to be used in a class we are still working on, which is going to be called resampling, and will allow resampling of audio signals and even impulse responses with the highest accuracy possible, with an implementation which is as fast as possible as well, using lookup tables.
Yeah.
And this class and the convolution one were probably the one I have spent the most time on them. And we have also the ballistics filter class, which is very cool because you can use it in any dynamic processor for making envelope followers. And it can be used also for visualization algorithm purposes. For example, to have a volumeter which acts smoothly with a given attack and release time. They are not. It's not a very complicated class with a lot of very complex DSP, but something that can be very useful in a lot of places.
Wow!
And there are tons of little additions like that, like the dry wet mixer or the banner class, which can be helpful for a lot of people, I think.
Yeah, that's going to some of that stuff like the dry wet mixer and things like that. Those are going to be absolutely magic.
It's not that complex, but that can be very helpful to make coding with JUCE easier.
Yeah, absolutely. Wow! So congratulations on that. Can't wait till that comes out. Yeah, it might actually even be out by the time we actually release this podcast. But if not, it'll be out very soon. And we'll definitely have loads of tutorials on that as well. Great. So I think this is a good place for us to wrap up now. Do we have anything else we need to talk about? You can think of?
I think we have talked about a lot of
yeah, I think so.
I guess.
Yeah.
I think I talk too much sometimes too.
No, it's great. It's great. So, so let's go ahead.
Yeah, there is one thing that I would say.
Yeah, go ahead.
Would be a nice conclusion for all the topics we have talked about, which is that, to me, the thing which is the most important for a DSP engineer is the ability to learn new things. When you are able to read, I would say, a DefX article and code all the stuff that is inside, then you're good.
Yeah, that's absolutely.
It's a very, very important step, I would say, because at the beginning, depending on the DefX article, of course, for everything is not in your language at first. Yeah. Every single time some mathematical knowledge you don't have is involved, you don't understand, and you just say, okay, it's not my language. I'm French, and it's Japanese, or I don't know. I can't read it at all. And when you start grabbing new stuff, of course, you get the knowledge that make you able to read that article you couldn't read before. But at some point, you learn to learn if you want. And to me, that's the most important step. At some point, you need to have enough confidence to say, okay, I don't know this topic at all, but I will grab some information in other areas possible. And at some point, I know I will get it.
Yeah.
When you're there, then you're not a beginner anymore in that. You start to be in the level after. And when I was giving lessons to people related to DSP about the knowledge I know, I was always saying them that that's the most important thing, that they can be able to research topics on their own and experimenting stuff on their own, grab the information where they need to. And to me, that's the coolest thing, when someone who was a beginner is then able to say, okay, I need that. I'm going to find all on my own solutions to my problem, implement them, play with them, and keep the best one.
Yeah.
And when you're there, you're already, to me, a proper DSP engineer.
Yeah.
So what I would like with the lesson that we're going to work on together in the upcoming videos, etc., is to help people to be there. I would say.
Yeah, absolutely. And I think what you say is a great key to also being able to code audio apps in general effectively, or just even code effectively, no matter what type of coding you may be doing, is the ability or the confidence. And I feel like I'm just starting to maybe get there in terms of where when a situation comes that you don't immediately know the answer, but there's this confidence that you will figure it out. That you have maybe some sort of intuition of what it could be, and then you know that with time you'll be able to actually pull the resources to actually figure out the solution to the problem. And I think that that's the key there. Yeah, that's a great note to end on. So great. Thank you very much, Ivan, for your time. And we have so much stuff that's coming out in these next couple of weeks and months, and I'm really excited for it. And where can people get in touch with you, Ivan, if they want to get in touch with you for anything?
Oh, I think they can get in touch with me using Twitter, using Facebook, on the JUCE forum.
Yeah. So his company is called Musical Entropy. Mm-hmm. So, and that's your Twitter handle, right? Is it Musical Entropy?
Yeah.
Yeah. So
yeah, exactly.
Yeah. So.
Yeah, I have a company too. I have not a company, but yeah, I'm trying at some point to release commercial plugins. It has always been delayed for tons of reasons. But I try to invest some time on it at the moment. And I have already released a few freeware plugins also, by the way, that are available on my website. And I think there will be a lot more in the next years. But yeah, it's the brand name associated with my personal activity in the plugin industry.
Yeah, so be sure to follow Ivan on Musical Entropy, and you'll find him there. You'll also find him. You can also find him in the Discord as well. So on that note, we will sign off. And once again, be sure to come join us on the Audio Programmer community at theaudioprogrammer.com/community. And we will see you next time.